As soon as you say you're retired, yeah.
Hey everybody, thanks for coming out tonight. As you can see, we're definitely in for a treat. I personally can't get enough of the IoT stuff. It's super fun, and there's just so many places to go. So we're going to get into that a little bit. But first, thanks again for coming. This will be the last meetup of the year for us. I expect for next year. So next month even. So if anybody has any topics or anything they want to cover, please reach out to me. I want to fill up our schedule. Also for next year, there's a couple of different things that I want to try. So far we've been kind of a meetup that just does presentations, and occasionally we'll do like a Jazz or a Hackmate or a lightning talk. Next year I want to try a couple things like, have you guys heard of Crampton? I'd love to go there like one Saturday or something like that and get a bunch of people helping them like rebuild computers. Something to get us a little bit more involved with, giving back to our community. So let's try a couple things like that next year. Also, I don't know if you guys, or how many people have kids, how many people are on Scratch. There's a bunch of Red Hat work at Red Hat. They've got some documentation on how to do like a Scratch session. So that would probably be another thing for us to possibly do that. And if anybody has any ideas on what they would like to do with this group, it's our group. We do whatever we want. So I'd love to hear ideas. And thanks to Melanie for hosting us tonight. It's always a great place to be here. Even have the workforce section. Yeah, please. And Tech Systems, thanks for bringing the pizza tonight. So give Tech Systems, the guys here, a couple minutes to do a job.
Hey, thanks, Kyle. It's good to be here too. I can introduce myself as Alex Gunter. Focused as a web developer for Tech Systems. I'm actually working on a requirement for Red Hat right now, so user experience design development role. But we see a lot of things, so I would challenge everyone to grow a relationship with a recruiter. We're more than just an annoying phone call just might get here and there. We can really be a resource, and I hope that we can prove to take that forward.
Absolutely. I'm Luke Ranky. I'm a senior colleague with also specialized in front-end developers. Going on that, we do have a couple of different positions. I don't know if you guys know anybody here, I do yourselves, because it's interested in the market. Kind of a higher position, doing some JavaScript Angular, we also have front-end opportunity. So I know a lot of people who are usually interested in that. So we have some of our cards, so it's kind of going on the table, and we're actually interested in kind of this is what we're talking about. If you have any questions about Tech Systems or just the market, like I said, we can reach out. So thanks, and we're going to run a pizza.
Thanks for having us here. Thank you.
So, announcements. Anybody have anything they want to share? Anything cool? This is always the tough one for me. I was asked if someone went to a conference. Has anybody released something? No. I'm sure you have. Any other job openings? Anybody have any positions that we can fill?
She's probably true. Right. Hi, I'm Mike. I work here. Usually I like to say I'm telling you how many people we're hiring, but it's kind of coming to an end at the end of the year. We are finishing our transition to the Raleigh-Durham area, and I think they're closing up the final reps. But obviously, we're a big company, and there's always jobs that are open and available. So if anybody's interested in a job, IT, from project management to programming to networking infrastructure, production management, we're always going to be hiring something. Feel free to pick my brain anytime if you have questions on what jobs are or what's like to work here. But that's all. But, yeah, we're doing a cool project with we're going to try and start something up with a Raspberry Pi and developing. I'm sorry, not with a Connect. Sorry, we're doing a Connect project for using motion detection for navigation on projects. And Jenny would tell you all about it, but she didn't do it. There's no JavaScript involved. Maybe we can add something. I don't know. Yeah, maybe
there's definitely drivers that know that stuff. So
I think didn't somebody do a presentation once with a Connect using JavaScript that they were showing for like the art display in Durham?
yes, that was the guy sitting next to at work. So he did this whole project called Commotion, where he used to Connect and wrote the whole thing in Node and D3 to do all sorts of visual representations as you're.
Can I get a connection with her?
Yeah.
Sure. Role model software is looking for senior web development help, like Rails, Angular, space, also front-end development, also project management, and they need designers too.
Okay, cool.
Yeah, my name is Davidson Wicker. I'm the founder of Breakthrough. We're a business management platform, and we're looking for JavaScript developers to join our team. So we did a main stack, Angular, Mondo, Python stuff. So send that here to my team with a leadership.
Who is that?
Yes, I keep them too. So obviously I'm from Practicam. We are also hiring CoffeeScript developers, JavaScript, CoffeeScript web developers, testers, people who are interested in the Internet of Things domain, instrumentation, scientific instrumentation, web technology, those kinds of things.
Yeah, so I'm here, I'm the co-founder of ProAction. We make this device that's used for industrial monitoring. It's a vibration monitoring. Sitting in a factory full of equipment that rotates, and that it wears out, breaks down. We monitor vibration that JavaScript running here, JavaScript on the web UI and all that. And we run the version of needing some help. I do this coding, but I can use some help. So didn't want to learn more about the system, didn't actually see the effort. We are hoping to get funding to somebody on the website.
I think I'm hearing January presentation.
I warehouse big, gigantic industrial things.
Nice.
I think JavaScript is everywhere. Some of the JavaScript. So, all right. Anything else? All right, we're good. So, take it away.
All right, great, thank you. So, as I mentioned, I'm working with Practicam. We do scientific instrumentation, like the example that we have here. This is a chromatography system that's used in a lot of pharmaceutical industries and a lot of chemical processing systems. My name is Jaz, and as I said, we're hiring, of course. So just, I'm going to briefly go over the science and just a high-level overview of what the systems do. Generally speaking, chromatography is the science of separating chemicals of biological compounds, molecules, and the end goal is to either purify or determine if there's impurities in samples, do drug discovery, things like that. Some of the companies are what they're doing. These pharmaceuticals, they're engineering cells to create proteins, and then when they break those cells apart to get the proteins of interest, there's other proteins that they don't care about. So they use chromatography to separate the proteins of interest from the junk proteins. This is a high-level overview of our fluidic diagram. Effectively, we have two fluidic pumps. They pump fluid from up to 8 buffers from each source, port A and port B. In the industry, we typically control these at very high precision to allow us to define the ratio of A to B, and in the industry it's called percent B, how much percent B you're pumping. So if I pump this twice as fast as this, that generates a percent B of 67%, 33%. And when the two fluids come together, we mix them fluidically and then pump them into a collector, or a column. This is an example of a column. Columns can go from really tiny little devices like that to industrial room-sized columns. The columns are generally a body containing material that has chemical properties that selectively bind to the products that we're pumping through. Specifically, they bind to a special product, the sample product, the product of interest, which has the proteins that you care about, and also the proteins you want to get rid of, the separation, the thing you want to separate. So once it comes out of the output of the column, it goes into a set of detectors. In our particular instrument, we're detecting 2 UV channels. The absorbers of 2 UV channels, UV light, 280 and 260 nanometers, if you're interested. 280 nanometers tends to be blocked by DNA. 260 is, protein. 280 is protein, 260 is DNA. We also detect conductivity because we use saline solution to help with the separation of the proteins. The chemical processes in that column are dependent on the saline solution, the salinity, how much salt is in the water or in the fluid. Then, based on that information, we can choose whether we want to collect the sample into test tubes or just throw away the sample. Or collect it in a different vessel. There's several different choices there. So generally speaking, fairly simple from a schematic diagram. It's just making decisions based on signals that we read and control the fluid that we put in. Surprisingly, though, it can be a little bit more complicated once you get into it. Just a quick example. When we choose how much percent B, how much of the saline fluid we get into the system, the time when it actually comes out to the detector is delayed by the size of this column, which could be a few, 10 seconds, or it could be a few hours. And in our software, we have to account for that because we don't want to flip that valve until the fluid actually gets to the output of that valve. So tricky things that you don't think about because you just think, well, you put fluid in, it comes out.
You also have to characterize the affinity of the of your I forget what you call it, but the
media.
Yeah.
So usually the chromatographer is very interested in how the media inside the column of material, how it binds to the product of interest, and that's part of their process. And they tend, sometimes they're experimenting with different media to determine what's the most effective affinity, and also how much percent A, percent B will percent B will actually generate the product they're interested in. Just an overview. So software, when you're generating instruments, when you write software for anything, you care a lot about the user experience. When you're dealing with scientific instruments, physical objects, you also care about the usability of the devices. So just to give you a background of, like, an example of where these things go, they often sit in labs where lab benches are at a premium. The space is really critical. And you do see ancient computers sitting next to these labs. And you see this is a gas chromatography picture, but with our system, you'll see probably hundreds of bottles and test tubes all over the place full of fluids. So that's something that we definitely want to keep in mind. Our instruments go into iteration units as well. And the more you can get into a single unit, the better it is from a cost perspective. It's also another factor to think about. Here's some examples of instruments in the past. Just to briefly go through, you can see a lot of similarities. They tend to be vertical to save lab space. Although some, apparently the more modern current ones, try to take up a lot more horizontal space as well for some unknown reason. They try to look big, even though they don't have to be. Some of these units, the previous one I mentioned, is like this big, like behemoth, and it doesn't have to be that big. It really doesn't. This thing, you can fit three of these horizontally, where one of those has to, and that thing you have to be able to rotate so you can get on the sides.
It may be like store shelves, like the cereal aisle.
Mm-hmm.
How much store shelf you occupy is your importance.
Yes, that's true. So as an example of our system, we also have to deal with robotics and controlling robots. So one of the fun things we really like about working at Practicum is we're writing web interfaces, web UIs, JavaScript to control physical devices, the movement of robotic positioning, arms, and turning on valves, turning off valves, or motors and pumps. So there's examples of different types of robotics. This is a rotary version. This is a linear version, it goes back and forth. Going to the software side, I think that's a good example of before even there was any pumps, you use gravity to do the same sorts of things. I've also heard of people taking the readouts from chromatography, and when they printed on the paper, since they didn't have software to do it, they cut the trace out and weigh the actual piece of paper to determine the area under the curve.
It does that. So that's not old.
Well, it works. So, however, we care about the software side of things. We can do a lot for the industry when you look at the software, and I'm going to go through a bunch of examples of where you can see a lot of problems. It's pretty sad. There's no real incentive to invest in the software or in the instrumentation, so companies don't. And so you look at some of these systems, a lot of these systems are almost always Windows-based. They're embedded Windows CE. You see things from the 90s and the 80s even. You see a lot of archaic user interface, user experience designs, modals on top of modals, tables for entry fields, wizards, all the other things we don't really want to see anymore. And the big problem is the people who are going into the labs, people who are being hired by pharmaceutical companies or other companies, they're coming from the universities. Some of them may not have even seen a floppy drive, right? What is a floppy disk? They are much more familiar with the stuff they see on their phones, on their tablets, etc. So some of this is going to be pretty baffling. And once I show you some of the, so as we go through some of these, you'll see how problematic they can be. So just generally speaking, the UIs, a lot of times what you're going to see is you need another entry field. Well, I'll just stick another one on the page. It doesn't matter where. You'll find it somewhere. They just throw them together. And you can see, again, it's like the old Windows toolbars with the floppy disk, save buttons and print buttons. Here's an example of a lot of times you'll see tree structures because you as a user are supposed to go browse for your files in some file system, which may very well be C:/program files / some application / data current data slash 2014 XYZ, whatever it may be, and you've got to dig through that tree to find it.
And when you say Windows, it might be Windows 9.5.
It may very well be. It's very true. Another area of problem. So there's no real indication of lights are on or off plots here. I think you have to either right-click or left-click on something, just a name, and it just turns off the particular plot. They oftentimes you see the same color being used for different places. There's a lot of bizarre things going on. Another example of a UI, at least they have labeled their graph traces. This one has an example of another really difficult thing that companies have put into the customer's hands. They expect customers to write programs to run their instruments, like, go to, all that kind of stuff. So actually, it'd be like pump port A 5 milliliters per minute. But that we could live with pump port A 5 milliliters per minute, whatever, that's fine. But they also throw in things like pump buffer same as prior. And it's like this bizarre language where you have to remember, oh yes, prior was something else. And it's not even that easy to understand what I just described. It's like some weird arcane language that some scientist came up with 20, 30 years ago and thought it was good enough for everybody, and so they solved it. We can do a lot better than that. We can put a UI on this. We can make it easier to use and make it more intuitive. And again, another example of trees. At least this one has some pretty visuals. But, a lot of the Windows examples are more modern, I guess. But you're still browsing C:/chem32, so whatever. It's kind of silly. Another trees, a lot of table entries. More trees, even more table entries. So, we're all in the web development world. We can do better. We have solved a lot of problems, probably very similar types of problems. The instruments typically so when I want to do something with the instrument, I want to send a command to it and have it respond and then tell me what's going on. Ideally, I can maintain a connection and keep getting that feedback saying, hey, my pressure's going up, and the software can react to that. A lot of those types of problems have been solved online in other applications, e-commerce, stock trading. If I want to sell a stock when it hits a certain value, I can save that in my stock trading software, and it'll trigger behind the scenes. So those, it's all well-known things. We just need to apply it to instrumentation. So again, like I said, we want to know about immediate things that are happening. We want to go and look at past things. We want to do things, actions. We want to save things. On the server side, the server may need to know how to schedule things or do things based on triggers. Needs to think about automation and track state. Very similar things to what you would do in any other web type of application. So this is an example of the UI. I'll just briefly go over it and then actually go over some demos. So we've taken the main things that people want to do. They do want to run things sequentially. It's what's called a method. A method is a series of tasks. So we say, well, if you want to run a method, then there it is. You can pick a method and run it. And also, a pretty common thing is to be able to do quick actions, such as priming the pumps. When they first receive the instrument, or they want to get rid of the air, get fluid into the instrument. And so in older systems, you have to create like a big setup just to do that. Why are you forcing people? Why are we forcing people to do that? Why not just say, pick the solution you want and click the button and it'll prime? We can do that. It's not that hard. And then there's a number of quick task actions to do the other things. This is an example of setting up a method based on a number of steps. So this is a method with a step for what's called equilibrating, and then upload, which loads a sample into the system. And simply just change your parameters. You click on how long you want this step to run and change it. And then whether you want to have it auto-extend, and then continue on, set other parameters as necessary, and then hit run. So everybody can understand with the green button to be run. This is an example of chromatogram, which is the data output. We're using D3 for that. And we have the ability to set annotations, or you can turn on or turn off the traces just by clicking on the buttons below. Pretty straightforward things to do. Up top, we have like a dashboard, so you can see what's going on with the system. And then we can also add things like progressive disclosure. You can, if you want to see more details about the run, you can open things on the side, things like that. I guess I will mention one other thing. So it is a challenge to do. One of the challenges I run into, instrumentation, the company run into, is customers do still want a lot of information. So fitting it all onto one web page is a challenge to make it still usable. It is still, there's a lot of things. But you have to keep in mind that these people who are using these instruments, the scientists and the lab technicians, they're not visiting a website once and browsing it for 5 minutes and then going to somebody else. They're day in and day out working with the instrument. Yes, we want to make it easier to get that early help, but we also want to make sure that they have all the information that they need. So there's kind of a balancing act there too. And then you also want to make it usable on the pattern, so you have some bigger targets. I'll go over the technology stack and then I'll hit some code. So this instrument, we have a Linux board sitting in the back of the instrument. It's an ARM-based quad-core board, little tiny, actually microprocessor plug-in board. It runs a variant of Linux, and on the front end, you use a browser. Why not, right? Why can't we use browsers in 2015 to control our systems? So the browser communicates to that Linux server board, and then the Linux server board communicates to the microcontroller boards that sit on with each of these devices. So the pumps, the valves, the detector. Each device is a little module that we communicate with. Typical front-end stack, HTML5, CSS3, Jade, whatever, class, stylus, whatever you want to do. CoffeeScript, we use Angular, Angular 1 right now. We use D3 for rendering the data, and Bootstrap for stuff. Then for communication, the communication stack, REST is REST WebSockets. We actually have 2 WebSocket servers I'll go over. And then as far as the middle layer services, we have a Postgres server sitting on the system. That's the neat thing about it. You get pretty much everything you want running on a little kind of chip these days. Kind of amazing that you can do that nowadays. But yeah, with Postgres, and then Java is doing a lot of the coordination. The client, the web client, connects to Java. to get REST and WebSocket communication. Java connects to Python, which then connects to a little embedded microcontrollers. You might ask why Python? Well, it's more convenient to write Python code to talk to serial devices than Java. I kind of want to get rid of this Java layer entirely. I don't think I'd go to Python, I'd go with Node, but it doesn't really matter which way it goes. But yeah, I could easily see this being replaced with a JavaScript type of system. I've even toyed with, or thought about whether it could be a Meteor system, which is kind of fun. So, okay. So, now I have to connect to the actual instrument, which means I'm going to go offline. I think. But this should still work. So I'm going to go from the bottom up, I guess. So obviously, so the data on the system, we want to be able to get, this past run information. We want to retrieve it. Kind of naturally goes with REST. You get data and retrieve it. So I will do that.
Can you run a clear so we get
Yes. Okay. So let me make it bigger too. Typical REST type of things you would do. You get from some source. Oops. I'll get all
Might be
the
too big,
methods.
Jazz. It's kind of
Oh,
wrapping
it is
around.
big
It's
on
hard to
that.
see what the
Sorry.
commands are.
Yeah. Is that better? It doesn't even have to be that big, does it? Is that good? So I can get all the methods on the system and just perform it. It just returns that stuff. I can do the same. Whatever you want, you can get. You can whatever you think of. It's just the typical things you want to do with REST-based stuff. So, oh, actually, I wasn't even going to the instrument, but anyway, you get the idea. You can do REST stuff. I was going against my left. You can get the state of the instrument. Or yes.
Do you worry about security yet?
So yes, that's a good question. So security is an important question. So every customer of ours is going to put these instruments in a lab. That lab is behind a firewall. It may even be behind a firewall where this can't even get out. However, you could have people local to the company who are doing that.
Or a virus that gets in your
Right.
intranet.
Yeah. So it's not Windows, that helps.
Yeah.
But the same problem occurs with all instruments. The Windows applications, Windows systems that I talked about, so they don't do this. They don't allow you to do any API stuff. About the only thing you can do is file sharing, if you even have that. Sometimes it's simply you have a floppy disk and you transfer data that way. It's really kind of archaic. So yes, security is a concern. We try to make sure we're keeping that up to date. Another concern is that once this is deployed, it may not get updated for 5 years. We don't have access to it. So different from when you're generating a web application that goes online, when you discover some security vulnerabilities, you can deal with it. You only have to publish it on those systems. So you have to trade security with accessibility. The reason why we provide things like that is so that the companies can automate their systems. They may never actually want somebody to interact with the web interface at all. They may want to have a system over here that generates fluid that goes into here, and then trigger the system to do something, and then wait for the system to provide information to continue on to the next step. So providing APIs is definitely a useful thing for our customers. So the next page. Okay, so REST is great. It works perfect. It works really well for retrieving data, storing records, those kinds of things, documents, whatever you want to do. It really isn't that great for instrument control, at least in my opinion. The issues that I have found and I've solved using other technologies, things like when that instrument state changes, I want to know about it. I want to know about it without having to do a GET request. I just want to be told that the instrument state changes, and then I can choose to do whatever I want based on that information, as opposed to trying to deal with the long polling type of issues or timers and what happens when that connection dies and all that kind of stuff. In addition to that, there's a number of other things I really don't care about when I want to control an instrument, such as the complexities of idempotent requests or safe versus unsafe REST requests. I absolutely don't want to deal with client caching. If I tell that instrument to start running, if I did that as badly, I said, okay, get start pump. Obviously dumb, but the browser might choose to cache it and say, well, you already told me to start the pump. I already know what it's going to do, so I'm not going to do it. Right? I'm just going to tell you I did it. Right? Obviously, I wouldn't use get, but you get my point. And then there's things like cross-origin issues. I don't care about that at all. I just want to control my instrument. So at the end of the day, if REST was your only hammer, then everything looks like a nail. But REST isn't the right tool for controlling an instrument. Thankfully, WebSockets exists. WebSockets is a great way to control an instrument through web interfaces. It's pretty open-ended. You're not constrained to certain rules or verbs or whatever. Once you've made your connection, it's persistent. It stays up. So the server knows about the clients. The server can tell every client that something happened. The server can say, this client made a change. I want all these other clients to know about it. Those kinds of things, which means, for example, if I'm on one browser and I make a change to a method, the server can tell every other client the same thing. A Google Doc type of scenario, we put that in for our system too. So when a user is editing a method, everybody else will know about it. When a user starts a run, everybody else will know about it. Everybody connected to the same instrument. So client, you could also generate different clients that do different things. Some clients may only want to be able to start and stop a pump. Some things may care more about the full picture, like what is the state of the instrument, et cetera. So there's a lot of things you can do with the multi-tablet interface. Not necessarily related to WebSockets, but I just added that, I guess. Anyway, so the reason why I feel WebSockets works really well for communication with the instrument is it really does mirror what one would do if I was doing any other instrument control type of systems like serial communication. Typically, all you really want to do is send a command and have it tell you it's okay or not. Or you want to wait for the system to just tell you about itself, like its next measurement is whatever. If you think about it, you can also build like a layer what the client cares about. And so you can think about, well, this client will subscribe to all of the system events, but nothing else. Or this client cares about measurements and method events and those kinds of things, the data that's actually coming off the instrument. The caveat, of course, is because it's a lower level protocol, the world is wide open for you. It also means you have to define the protocols, how you communicate to the device. You don't have this HTTP request and then a tied response. There's asynchronous communication or two-way communication. So if you send a command and another command, and then the server responds or sends a command saying one of them failed, you'd have to know how to tie the two together, maybe with unique IDs. But that's on you now to define that, whereas a HTTP request would be tied with the response. Those kind of things.
What about existing message passing protocols, AMQP, MQTT, STUMP?
Yeah, so there are libraries, I think, for various different kinds of communication protocols and the multiplexing concepts that you want to do. I don't know specifically about those those existing ones, but it's not unusual to see, just to do that kind of stuff. I don't see any reason why you wouldn't. Let's put it that way. So it's really it's up to you to define it. You get the freedom, but you also are at the cost of building it. So, or you're finding a library that will work for you. So talked about the defining protocols. You have to handle, what happens if the message doesn't get processed. And then I mentioned before that this kind of system is something that a customer uses for a long time. That's actually a pretty big factor with WebSockets as well, or just anything that has a callback in general. Because a client is using the instrument for hours or days or weeks on end, they may leave their tab open to the system for that long. Your app better not memory leak. You better deal with your callbacks correctly and closures. Make sure you're dealing with you're not having a memory leak over time. And that memory leak may be slow, but become very significant. So definitely some issues, I guess, in general for closures, but because we're doing a lot of communication through WebSockets, that can build up if you're not careful. So, go to here. Let me just give you some actual routing things. Why not? So I mentioned that we have a Python layer and a Java layer. So each layer has a WebSocket protocol sitting on it. The Java talks to Python through WebSockets, the persistent connection. In addition to that, each one has its own level of protocols. The Python layer is less complex or more straightforward, I guess. So I'll just demonstrate some examples of that using, sorry, here. Just use some node type of things. So I'm pulling in a WebSocket NPM library. This is 1.145, right? 145. So connected to the WebSocket server. It's a persistent connection. and I can listen to events that come off of it. And just whenever it sends me a message, sorry, it's getting low there. So I'm just going to listen to any messages, and whenever I get an event from the message, I'll just console log it. And then I'll send it a command in JSON. Okay, that didn't work. That's weird.
You tell it.
Well, I didn't hear it. You're right. Well,
No clicking.
Yeah.
Physical things that move.
It's nice to have physical things that move until they crash.
Yeah, you're right. How do I know? So there's, you can listen to screen. Stop screening. And I'll start screening to see what it has to say. Let's see, responding to that. They worked in the office.
Every demo.
Yes, that's annoying. So the command was successful. That's what it says, I guess. That's difficult.
Can you reboot the physical device controllers?
Yes, I'm going to.
Does that take that might take a while.
It'll take a few minutes. I'm going to try it first to see.
Ooh, that worked.
It's working. I must not have separated. Okay, so I'm going to start from the. Something is really acting odd. It shouldn't be doing that either. That's actually pretty bad.
It isn't.
My camera set up at all by any chance so people can see? I think the.
No, I can't.
Well, yeah, we can't. I don't know how to.
What are you running? You're running Periscope or Google Hangouts?
It's on Google Hangouts.
Can you join Google Hangouts on this?
But he's not on the network.
Yeah, I had to switch networking.
Oh.
I mean, if you want to see it, what's on the Google Hangout, it'll be delayed, but you can go to there's a link to it in the meetup.
Okay, well, when all else is in doubt, reboot.
There it is.
So we'll have to wait a few minutes.
Happens to all of us.
Yeah.
At least he knows
Is it connection based or connectionless? And is it possible that you've got a serial or a resource that's being allocated to a different window, your UI or whatever? No.
No, it shouldn't matter.
Sure.
Yeah, it should. I don't know why.
Take commands from anywhere.
Yeah, exactly. So you build things on layers, right? First, you make it work without security. We've actually, over the last few months, added the ability to control who can do things. So again, you have to think about, well, where does authentication come from? Do I really want to stuff users and passwords into that device? No, not really. So we've been building up services on and using Meteor to allow users to manage manage their logins, manage their laboratories, and then this instrument can connect. If it can connect to the internet, it can get that information, and find out, well, these are the users who can actually run the instrument. These are the users who can administer the instrument, those kinds of things. Okay, so let's reload here. Let's see if this works. Okay, it's working the way it should. So I'm going to start from the website so you get more of a context anyway. So like I mentioned, quick task, choose the fluid, start the run, really simple. Actually, if you think about how phones have been kind of, a novel thing for people over the last decade or whatever, just taking some simple concepts into the world of science is like mind-blowing for these people. They, just being able to do something simply is pretty big. So it's the same, if you go back 15 years ago, you took your phone, all the technology you know today, took it back there, you'd be just living in this domain, frankly. So, okay, so here's an example of priming pumps that actually work, thankfully. Another example where they want, customers want to take all the up to 16 bottles and purge the air out of each one of them sequentially. So this is an example of where all the code behind this page, what it's going to do is send a JSON object containing some information about which buffers the user chose, and a command that says purge and fill buffers. The Java server is then going to say, okay, well that means I'm going to first, in this case, actually pump buffer B, and then fill with buffer A, and then for each of those, I'm going to use 10 milliliters of liquid. So Java is going to then define a series of steps or method that does that behind the scenes. I'll change it to a couple milliliters each. So it should go and pump buffer B for 2 milliliters, which will then you'll see it pause and then change the valve location and go to buffer A. So you can see it started at buffer B of 100% versus 100% B, and then it's going to switch the valve to, or actually switch the valve and then went to buffer A here. So this delay here is an example of some of the things you have to think about, that even though you've chosen buffer B today, or right now, a few milliliters later, after it gets out of the column, it actually is at 100%. So this looks asynchronous because, or not symmetric because of that. This is a measure of the actual output that's coming out of the instrument, which is something that customers actually prefer. So kind of a weird thing, but it's true. So that's some of the quick tasks examples. You can see where we're using D3. All of this is a single page app, Angular application, Angular directives for each of these little items. This little button, this little panel is an Angular directive that defines information about the column, this little device, how many milliliters of fluid it has, some of its parameters. So this is the method. And again, another directive, a thing that picks the quantity of %B, solving some of the touch panel things by giving a touchpad instead of having a keyboard pop up on a touchpad. That tends to be interrupted when you have to do it 100 times a day. It's easier to have a custom generated keypad. Was there a question? No. I'm actually also going to duplicate this tab so you can see things like the state showing up in both tabs. Actually, yeah, let's move this into here. And you can see things. So here's an example of I send a WebSocket request on one browser and then get published to another browser. All these things are the UI has subscribed to and it cares about it, and then demultiplexes that information into the various areas that care about it. You know, Angular services that care about various parameters. Okay, and that just continues to run, so that's fine. Okay, so now I can go back down the stack to the more primitive stuff. So before I do, any questions so far? All right, so so all I'm doing is making a WebSocket connection to the client, to the server. This is the Python protocol bridge. It has an endpoint called pump for 8765. WebSockets start with WS as opposed to HTTP. Not familiar. And so any message that I get back from the WebSocket, I'll just console log it. And you can see I started pumping. Okay, pretty straightforward. And yes, I agree that if the system had failed, they really should have returned me some command message or something saying something didn't work. The Java layer has more code that looks for error states, such as the pump system didn't tell me it went to 0 volume, for example, which it's supposed to have done, and it did error out. This layer doesn't do it from this level. So anyway, you can see that's pretty straightforward. Communication. I'll actually do another one real quick. There's copy. Correct. For communication, I'll show you some of what we do with REST. I find that REST is is really not well suited for REST is really not well suited for controlling the instrument. WebSockets is just a command like send start pumping. You know, it's quite straightforward. It's just this is what I want you to do. Just go do it. You know, I don't want to think about cores. I don't want to think about which verb to use. I don't want to think about all the added things that come along with REST. I want base stuff. And actually it's the same sort of things you have to think about when you're doing normal communication, like the traditional communication over serial or over USB. You don't want to have things get in the way. I don't want caching to block me from doing what I want to do. So that's why we use WebSockets. And you can do, you don't have to do any REST at all. You can do everything through WebSockets as well. For example, Meteor.js does all its document transfer through WebSockets with an additional layer or set of layers on top of that, of course. Okay, so something new. I'll just do this again. And I'll connect to the collector. So there's several modules. We have pumps, we have rotary valves, we have a detector that provides feedback, and a collector. I'm going to connect to the collector. New, and this. So just open a connection like I did before. And I'll listen to messages that come from it. And I will send a kind of a convenience command. So all of our communication, so this is actually slightly different than what you would have done 20 years ago with serial communication. Back then you would send bytes and encoded like little tiny things because you kind of cared about bandwidth. We have a lot of bandwidth, so why not send JSON? Makes sense, right? So I'm sending a JSON object, JSON string that represents a JavaScript object, and I get back JSON. So I'm just saying, hey, what commands does the collector have? Well, the collector provides those commands, and I can just then send one of those commands to send. Get all recs. So what kind of recs does the collector support? Well, it's a big JSON thing that says that I have a bunch of vessels you can go to, and here are the locations of those vessels. So go tell me which vessel you want to go to. And I'm not going to just type it out. I'll just copy and paste it for simplicity's sake. So I just went to collector vessel 1, and go to collector vessel 10. So, and this one will actually error out if I get the incorrect decimal stuff. So at least we have that. But yeah, I mean, it's pretty cool. You can imagine, you know, if you have all these commands at the Python layer, it makes it pretty straightforward to coordinate those things at the Java layer. Similarly, oops, I forgot to end that session. Close the connection, so it's kind of pending. Similarly, I can do the same sort of thing at the Java layer. So the Java layer has more error protection. It cares of every command that I send to Java has a unique ID. I use a UUID just for convenience to ensure it's unique. But you can send any string actually. So that you can pair up the request you sent with the response you get. Then, you know, I build a stack over that to pair them up so that it's easier to put a promise around it and then respond with it, you know, using the promise mechanisms. So let's try that. And let's go here. Yay! All right, so now what I'm going to do, instead of connecting to port 8765, which is our Python layer, I'm going to connect to port 83, which is the Java's WebSocket server. And I'll also listen to messages from the Java server. That helps. And then I'm going to send a really long command. Which I have here. Oh, great. So client.send. Oops. And I need an end quote on that. So that's a big JSON string, but all it does is do the same thing as a quick task. And again, you can imagine it's pretty simple to create an object in JavaScript, send the command through to the server, and then have it respond. And so the Java layer is more talkative, I guess is the way I'd say it. We get a lot of information back. We want that because we have to graph what's happening on the server. We have to project how much time is left. Those kinds of things are important to our client. So we publish it back through WebSocket. And just end the run with a stop instant run. And this time I will remember to close the connection. So it stops. Okay, so, but as you can see, Java is giving more information because we want more information in the UI. So, and actually, since I was communicating to the same Java server through WebSockets as the UI was connected to, it responded saying, oh, somebody had started a quick task, so I'm going to switch over to the quick task panel, and there's the data coming off the instrument based on the quick task that I had sent as JSON. Pretty straightforward concepts, I guess. So, yeah, I think that's about it, actually. So,
Excellent.
cool.
Very nice. Very cool.
Any questions? Yes.
What is your team composition right now?
So we have 3 web developers, web type developers. I do some of the Java as well. I have a tester who also does a fair bit of Java. We have a firmware developer, the C++ Python developer. And actually that's why we have this split between Java and web technologies, Python, C++. He knows Python and C++. So that's why that's in Python. And then we have mechanical engineers, a mechanical engineer, designer, graphic designer for the user interfaces. So obviously we have this software. We also have the Meteor application to manage users. I have it running. So we have a web app, website, and then we have a web app. That's a Meteor app. We developed that as well. And then there's, like the owner of the company, HR, those kinds of people. Might not have the web app running. Yes.
Can you talk a little bit more about the interface to the C++ and the pumps and how that, so is there a service running or a background process? I know you said there's a Java and Python server, but.
Yeah, so from the very bottom layer, there's tiny little microcontroller boards, very similar to it is ARM-based systems.
Is it more like an Arduino or more like a Raspberry Pi?
Very similar to Arduino type devices. They communicate via serial, serial over USB, whatever. But they're fundamentally serial RS-232 devices. 16 megahertz, maybe more actually, maybe faster than that. And then the Python layer communicates directly to each one of those devices. And we call it the protocol bridge because it bridges WebSockets to serial.
Sure.
and back, both ways. So, any other questions?
WebRTC.
Do you guys struggle at all with Chrome being like available in these labs?
That would have been a question a few years back, yes. I don't think it's an issue these days. So WebSockets and IE